Now one example has been given, we will solve here for node voltage V1 and V2. So we know how to apply the matrix relation. So directly we are going to write now. So here two nodes are there, node 1, node 2. At those two nodes the voltages are V1 and V2. Those are node voltages. Okay. Then here how many principal nodes are there? If you take this ground one is a third principal node, n is equal to 3. So we are required to write two KCL equations because n minus 1, that means 3 minus 1 is equal to 2. So the conductance matrix size is of 2 by 2 only. Okay, n minus 1 by n minus 1. So the 2 by 2 matrix will get. Okay, so I am writing that one directly. You see how I am going to write. Diagonal elements are filled by the conductances which are directly connected to node 1 and node 2. Okay, so what are the conductances related to node 1? That is, one is from 2k, second one is from 1k. But these are resistances. So we need to convert into conductances. So 1 by resistance is the conductance. So 0.5 millisiemens that came from 2 kilo ohm plus 1 milli that came from 1 kilo ohm. Okay, these are the two conductances directly connected to node 1. Now what are the conductances directly connected to node 2? Those are because of 1 kilo ohm resistance and 4 kilo ohm resistance. So because of 1k, the conductance connected to node 2 is 1 millisiemen. Okay, so that siemens I am not writing anyhow. Units we no need to mention, 1 milli. Okay, then plus this 4 kilo ohm resistance is also directly connected to node 2. So its related conductance is 1 by 4k. Okay, that means 0.25 milli. So diagonal elements are over. Now non-diagonal elements we have to fill. So in the first row, that means it is related to actually node 1. Okay, so the second element of the first row will be filled by the conductance which is connected in between 1 and 2. Okay, what is that? 1 kilo ohm. So its related conductance is 1 millisiemen. But it is a non-diagonal, so that we have to put minus. So minus 1 millisiemen. Because of the symmetry property, according to transpose, we can able to write directly here also 1 milli. Okay, the second row is related to node 2. Okay, then it is multiplied with the this voltage vector, and then it is equal to current vector we have to write. And current vector, what is the current injected into the node 1? Minus 7 milli, because 7 milli is coming from the node 1, it is leaving the node 1. So in order to make it inject, you have to take here minus 7 milli. What is the current which is injected into the node 2? That is 14 milli. So writing the relationship, matrix relationship is over. Now we need to solve for V. Okay, V vector. That means actually it is G V is equal to I. From this we need V, that is equal to G inverse into I. This is what we need to perform. So for that we need to know what is G inverse. So first of all I am writing G. G is 1 plus 0.5, that is 1.5 milli, and it is minus 1 milli, minus 1 milli, it is 1.25 milli. Okay, then G inverse we have to find. It is in the form of A, B, C, D. So G inverse is given by 1 by determinant is AD minus BC, and here DA, this is minus B minus C. So it is equal to 1 by, what is A? 1.5 milli. What is D? 1.25 milli. What is B? Minus 1 milli. What is C? Minus 1 milli. So this is what we need to do. So I am applying that one, 1.5 milli into 1.25 milli minus 1 milli minus 1 milli. So I have written here 1 minus 1 by AD minus BC. Then it is multiplied with the D. D means what? 1.25 milli, and minus B is 1 milli, minus C is 1 milli, and A is nothing but 1.5 milli. So this is what we have to calculate. Then that is G inverse. After getting G inverse, to get V, what we need to do? This entire G inverse is in product with matrix I. Okay, column vector I. That is what we need to do. Okay, that means 1 by 1.5 into 1.25 into 10 power minus 6. Then it is minus it is 1 milli, 1 million means 10 power minus 6 only. Then here it is 1.25 milli, this is 1 milli, it is 1 milli, it is 1.5 milli, and it is multiplied with the minus 7 milli, and it is 14 milli. Okay, so if you perform this calculation, then we will get V1 V2 as 6 volts and 16 volts. Thank you.